Hello everyone, hope you're well. We have investments part 1, so that's in the book, Sequence of the Series, that's page 39, 40, and 41, if my memory serves me correctly. ARCO and HUA, like always, our ARCO is our learning objective, so how to convert between rates and percentages. Second ARCO, what we're learning, how to find TN when dealing with investments. Your HUA is just to solve those 4 questions in the book. I'm going to split this into 2 parts. The first part, we're going to find TN. The second part, we're going to be finding A, N, and R. So algebra in the second part, and this part is just substitution. All right, investments. Anything involving money typically is a geometric sequence. So what is a geometric sequence? Let's recap this. I always do this because it's good practice. So we have N, and we have Tn. N is the, very good, it's the term number. And Tn is the, very good, it's the nth term. So the nth term. What is the nth term? So, for example, this is the first term. This is the second term. And in general, we have the nth term, the first, second, third, 100 billionth, nth term. And so on and so on. All right, so geometric sequences, what do we need? We need an A, we need an N, we need an R, we need a Tn. So our A will be what? Yes, your A is your first term, so that's A. A. Ooh, it's a nice circle. A. I'll make it green. Let's be A. So A will be 100. Ooh, I don't like that. Let's change that. It will be 100. All right. What's R? R is the rate. So it's how much it changes by. You can always find that by going the second term divided by the first term. So 150 divided by 100 is 1.5. So our rate must be 1.5, or 50%. All right, N is just what you feed into the formula, and Tn is what you are finding out. What is the formula? Here's the formula. Tn, so the nth term, equals the first term A times by R to the n minus 1. For example, the fourth term there, I didn't figure out. So what is that fourth term? Let's find it out by chucking it into here. So the fourth term is 100, and R is 1.5. And our n now is 4, so 4 minus 1 is 3. So bring your calculator out. 100 times 1.5 to the power 3. 337.5. Kilograms or monkeys or dollars, whatever unit it is. So there's 337.5. All right, that's the first part of the review. Second part, percentage increase and decrease. So let's just do some examples and what R value that is. So for example, if we have a 10% increase, 20% decrease, stays the same, and doubles. Let's just say it stays the same first. If something stays the same, then you multiply it by 1. For example, 7 times 1 is 1. Sorry, 7 times 1 is 7. It stayed the same, yeah? If it doubles, then you multiply it by 2. So your R here, your R value would be 2 if it doubles. Okay, 7 times 2 is 14. If it increases by 10%, then we multiply it by what? We multiply it by 1.10, 1.10. And we get that by getting that 1 we had before when it stays the same, and adding a 10 to that, 0.10 to get 1.110. If it decreases by 20%, is it 0.2? No, it's 0.80, 0.8. To get that by getting the 1, minusing 0.8 to get 0.20. Examples. 2 examples. First one, Tom bought a laptop worth 1,500. Each year it depreciates by 20%. How much will it be worth in 3 years' time? Tom bought a laptop worth this amount of money. Each year it depreciates. I'll see what that means soon. At 20%. How much will it be worth in 3 years' time? Okay. To solve all these questions, you must first find out what the A is, N, the R, and the Tn. Let me just type this in a box because it's so useful, the formula. I'm going to be using it soon. Alright, so A, in this case, let's write all that down. So A is something, R is something, N is something, and Tn is something. I'm finding that from here. So A is what you start with. So we're starting with 1,500. Okay, depreciates means decreases. So it decreases by 20%. We just figured that out above. So that's going to be 0.80. That's what our R is. So decreasing by 20% means our R is 0.8. N, so in 3 years' time, is N going to be 3? No, N is actually 4. I'll show you why soon. And T is what we're trying to find, so that's the unknown. Alright, so why is N 4? So let's quickly talk about that. You know what? So let's just do some examples. So T1, T2, T3, T4. If you start with T1, that's what you start with, that's your A. Your A here will be $1,500, right? That's how much the laptop that Dom bought was worth. The year after, so 1 year later, it will decrease by 20%. So that'll be 1,200. Or in this case, it's A times R, so 1,500 times 0.8. 2 years later, will be a T3, and 3 years later, so 3 years later, is actually T4. Basically, always add 1, usually, most of the time, but to make sure you want to actually go through this process yourself, write down T1, T2, T3, and think about where's your starting point, where's your ending point. So you're starting at T1, you're ending 3 years later, so there must be 3 jumps. 1, 2, 3. 3 jumps means you're at T4. So we got all our variables, let's chuck it into the formula. So let me add some lines, make it a bit neater. That's nice. All right, and line there. All right. Good enough. All right. So our formula was Tn is A times Rn minus 1. So Tn we don't know. Leave it as that. A is 1,500 times R is 0.8 times, so the power of n minus 1, so that's 3. Calculator time. 1,500 times 0.8 to the power of button 3, 768. Okay, are we finished? No, we're not finished, because we don't have a conclusion. We haven't answered the question. How much will it be worth in 3 years' time? So, therefore, his laptop is worth $768 in 3 years' time. Question 2. Nina invests. Nina invests $10,000 in a bank, so that's our A. That's what we're starting with. At a return, appreciation, opposite of depreciation, of 4% a year. So that's going to be our R, same over here. So it increased by 4%. After 20 years, how much money will she have compared to just holding the money in cash? Compared. So it's a slightly different question. So what's our A? NTN. Right, so A is $10,000. Is it 0.04? No, it's 1.04 because it increases by 4% from the 1. N is 21. Yes, always increase at 1. If you're confused, do that little calculation to the left there. Also, it depends on the wording. It could say during 20 years or just before 20 years. If it's after 20 years, it's going to be 21. Okay, TN also we don't know. Right, formula time. TN is A times Rn minus 1. Chuck it all in. TN we don't know. Let's be a bit fancy, a bit different. Instead of saying TN, we're going to call it T21. So the 21st term or the money on the 20th year. So T21, because we know N is 21, is 10,000 times 1.04 to the power of 20. Put into the calculator. Whoops. 10,000 times 1.04 power of 20. 21911.23. Are we done? No, we're not done. Because the question is asking compared to just holding the money in cash. So compared to the original amount, which was 10,000. So we must go 21911.23 minus that, which will be 11,911.23. Therefore, she would have that amount of money more compared to holding it in cash. And here's the money in the bank growing. So she's put the money in the bank, $10,000, and every year it's increased. And after the third year, she's got this beautiful plant here showing that it's increased by $11,000. So it's good to hold the money in the bank for 20 years, sorry. Right. We should now be able to do these questions in the book. Questions 1, 2, 6, and 7. Do that now. And in my second video, I'm going to be talking about finding N, R, and A. So here, we're just doing examples where we don't know TN. And next lesson, we're going to be doing one where we're finding A, N, and R. Okay, thanks very much.